All right, so we're looking for the wavelength emitted when electron changes position. Um, so there's an equation from the book that looks like this. There's other equations you can use, but this one will work just fine. So it's 1 over the wavelength is what I'll get at the end, and so I'll have to do a little adjustment. Then there's a constant, h and c on the bottom, and then my initial n is the 4, and my final is the 2. So plugging in my constants, the 2.818 times 10 to the minus 18th, that's a constant, Planck's constant, and speed of light, also constants. 1 over 2 squared minus 1 over 4 squared. Okay, so now the trick is just to put this in my calculator really carefully. So, if you get to the same answer as me, then whatever you did is okay, even if it's not the same. I'm going to kind of break it down in pieces. So I first took the 2.18 times 10 to the minus 18th and divided it by Planck's constant, and then I divided that by the speed of light. So that's like all those constants at the beginning. 1.10 times 10 to the 7th. Checking my units, the only unit I have left here is meters. It should be 1 over meters. I have that wrong, but anyway. And then now I'm going to do the part with the squares, and I want to be careful with parentheses there. And I got 0.1875. That doesn't have any units. All right, so I'll multiply those together to get a number. That's not my final answer, but that's 1 over the wavelength. All right, so 2.06 times 10 to the 6th. All right, there I go. I fixed the meters. Okay, so 1 over meters, that's 1 over the wavelength. So now the wavelength would be 1 over that, right? Like 1 over the wavelength would be the wavelength. I'm taking the reciprocal, right? That's what I'm doing. I'm just flipping everything upside down. Right now it's 2.06 times 10 to the 6 over 1, so I'm flipping that, and I just put that in my calculator. 4.85 times 10 to the minus 7th, and that would be meters. It asks for nanometers, so I'll need to convert that. And I'm using 1 times 10 to the 9th, positive 9 nanometers per 1 meter. There are lots of nanometers in 1 meter. Put that in my calculator. You can't really see because there's a glare, but in the end, I got 485 nanometers.